You can wait 1 or 2 minutes more.
Okay. Okay, I think let us start.
Yeah,
this event.
let's start. Yes.
So, hello everybody. Welcome you all to this wonderful evening today. We have gathered today virtually to celebrate, three grand events of the Indian Association of Structural Engineers. Before I start, let me introduce myself. My name is Alok Bhaumik, and I'm the immediate past president of Indian Association of Structural Engineers. It's a great honor and privilege for me to be the moderator for today's event and to speak before this august audience. Before I start, may I request all the panelists to kindly make sure that their microphone is always on mute unless it is their turn to speak. Well, today, as I mentioned, there are three events that we are going to celebrate. The first event of the day is to give a special Lifetime Achievement Award to our founder president, the legendary Mr. Mahendra ji, who left us 2 months ago only. For those of us who knew late Mr. Mahendra ji intimately, personally, or professionally, it is so hard to find a celebratory feeling at this moment when we are going to give him this special award posthumously. We are proud of him not just for his monumental professional accomplishments, but even more just for who he was as a person. I only wish he could be there in person today to receive this special Lifetime Achievement Award. At least that is what the award committee had thought when they had decided to give this award to Mr. Mahendra Raj. The second event that we are going to have today is the first Mahendra Raj Memorial Lecture. This lecture was planned to be delivered originally by a well-known and eminent architect, urbanist and educator, Sri Balkrishna Doshi ji. But unfortunately, he is down with COVID and therefore he is not in a position to deliver this lecture today. In place of Architect Doshi, the memorial lecture will be delivered by Professor Mahesh Tandon. Architect Doshi was, of course, kind enough to send a video for presentation, which will be played before the memorial lecture by Professor Mahesh Tandon. The memorial lecture will be followed by the third event and the last event of the day, which is the annual award ceremony, IAS 2021. This is the second year award ceremony of IAS 30. We had 2020 award ceremony last year. In this ceremony, works of outstanding structural engineers and organizations having outstanding projects have been recognized. It's a great opportunity to celebrate the success, hard work, and commitment of the structural engineers in India. So this is the broad agenda tonight. And today's event will be for about 2.5 hours. And we plan to conclude this event by 7:30 p.m. So without further ado, may I begin this event by welcoming our President, Mr. Manoj Mittal, to give his welcome speech. Mr. Mittal is serving his second term as President of IAS Shakti. He is a practicing consulting civil and structural engineer, and he is also associated with the School of Planning and Architecture as faculty. Over to you, Manoj.
Thank you, Alok. Good evening, ladies and gentlemen. I extend my heartiest welcome to all of you in this important annual event. As you know, we started IAS Shakti Awards in 2020 to promote and recognize excellence in structural engineering. This is second year of these awards. A committee under the leadership of Professor Prem Krishna was constituted for this purpose, and response received from fraternity is very encouraging. Quality and number of nominations received in each category is a matter of great satisfaction for us. We further hope that these awards will gain eminence with time. I, on behalf of the association, welcome all awards nominees, past winners, and their organizations to this event. As you know, Indian Association of Structural Engineers was constituted in 2002 with Mr. Mahendra as its founder president. And he led this association from 2002 to 2010. Over the period, this association has grown in size, reach, and impact. It has members from all parts of India and some from abroad as well. It is known for its quality technical events, scholarly publications, continuing education programs, having credible pool of qualified and competent structural engineers, and being at the forefront while interacting with government for policy matters. It also represents in various standard making institutions like BIS and IRC. We also have MOUs with many important like-minded international professional bodies. We could achieve this because of the guidance of Mr. Mahendra. IAS Structure was his brainchild and he cared and nourished it as his child till end. He was a structural engineer par excellence and a great human being. All of us are fortunate to have known him. Our association has decided to start annual Mahendra Memorial Lectures from this year. Every year, it will be organized along with annual IAS Structure Award ceremony. This year, it was to be delivered by well-known eminent architect Balkrishna Doshi, but unfortunately, he has got the COVID infection. So now Professor Mahesh Tandon will deliver this lecture. A 15-minute video clip sent by architect Doshi shall also be played in the event. Mr. Doshi's lecture will be organized separately as a special lecture sometime later. I extend my warm welcome to Professor Mahesh Tandon. I am thankful to him for accepting my request to deliver first Mahendra Memorial Lecture at the last moment. I would also like to acknowledge the contribution and support of Mr. Rohit Raj, son of Mr. Mahendra, and Ms. Khushnu, granddaughter of architect Doshi. I welcome them in the program. You will also be happy to know that IAS Structure had decided that every year Mr. Raj's birthday, 11th November, will be celebrated as Structural Engineers Day. We will soon come out with detailed plans. I further extend my warm welcome to all members of IAS Structure, civil and structural engineers, architect friends, members of Indian Institute of Architects, students and faculty members. I am expecting this evening to be full of nostalgia, emotions, joy, and proud of achievements, hope for future and celebrations. I once again welcome you all. Let us enjoy the evening. Thank you.
Thank you, Manoj, for your welcome address. With this, let us now proceed with the first part of today's event, which is the special Lifetime Achievement Award to late Shri Mahendra Ji, our founder president of Indian Association of Structural Engineers. It is my proud privilege to welcome Professor Mahesh Tandon, the past president of IAS Structure, and request him to read the citation of late Mr. Mahendra Raj. But before I do that, I have the proud privilege to formally introduce Professor Tandon. He is also going to be the lecturer for the first Mahendra Raj Memorial Lecture. So Professor Tandon, Managing Director, Tandon Consultants Private Limited, is an international expert in the field of structural engineering. Many of the structures designed by Professor Tandon and his team in Tandon Consultants have been widely acclaimed and have received recognition in India as well as internationally. He has spearheaded the development of new codes of practice and path-making bridge technologies suited to Indian conditions. These include pioneering work in the field of segmental construction, integral construction, accelerated bridge construction, long span bridges, and structures for metro, both viaducts as well as the underground structures. He has designed several tall and prestigious buildings in India and abroad. Earthquake and wind effects on structures are his special area of expertise. His structures have been described as highly creative, futuristic, aesthetic, environmentally sensitive, and innovative. He has accreditation of International Professional Engineer India and is also a fellow of the Indian National Academy of Engineering. He is the recipient of Distinguished Alumnus Award of IIT Roorkee in 2018. He is currently chairman of Research Council CSIR CBRI. Under the AICTE program, INAE appointed him as Distinguished Visiting Professor at IITs, that is at Kanpur, Roorkee, and Gandhinagar. Currently, he is continuing as guest professor at IIT Gandhinagar. With this, may I now request Professor Tandon to kindly read the citation of Mr. Mahendra ji and do the honors, please. Professor Tandon.
Yes. Thank you, Mr. Bhaumik. It is a privilege to read the citation for the Special Lifetime Achievement Award, which is being given to Mr. Mahendra Raj. Born in 1924, engineer Mahendra Raj graduated in civil engineering in 1946 from Lahore and started his career with Punjab PWD in 1946. And after a decade in government service, he left for USA, where he did his MS in structures in 1956 from Minnesota and CE in structures from Columbia, New York in 1959. Back in India, he started his independent practice as a civil engineer in 1960. Engineer Mahendra Raj was a colossus, straddling 6 decades in the building profession, and his innovative and thought-provoking structures demonstrate his unmistakable mastery of the medium. He worked with some of the leading and famous architects of the world, such as Le Corbusier, Yamasaki, Louis Kahn, Charles Correa, B.V. Doshi, whom you will hear in a delayed lecture, which will take place and we will inform you about it. A.P. Kanvinde, Joseph Allen Stein, and Raj Rewal. In his own words, our common objective was to set up practices here, find our own roots, and rise to the same stature that other countries had attained already. We sought an Indian idiom that expressed our ancient culture but was in tune with modern times. As imposing and jaw-dropping as his structures were, engineer Raj himself was most unassuming, soft-spoken, and highly approachable. His winsome mannerisms brought many reluctant professionals around to accept and promote his innovative ideas. Engineer Mahendra Raj made extensive contributions to the development of civil engineering profession in India. As the president of the erstwhile Association of Consulting Engineers India, he sponsored the cause of consultancy in India for a number of years and was passionate in framing a legislation for regulating the profession of engineering in the country through the Engineers Bill. With the support of all professional organizations in India, the Government of India instituted an Engineering Council of India with the assurance that the legislation of the Engineers Bill would follow. Engineer Mahendra Raj was actively involved in the FIDIC since India became a member in 1981 and received recognition from several professional organizations for his outstanding contribution in the field of building industry. To name a few of his awards, they came from Institution of Engineers India, Association of Consulting Civil Engineers, the Chairman's Award in the series Architect of the Year Awards, instituted by JK Cement Works. This was the first time that an award meant for architects was given to an engineer for his outstanding contribution in giving architecture in India a new aesthetic dimension through innovative structural systems. So that is what the citation will read when it is handed over to, I think it will be Rohit, but now let me go back to the moderator, Mr. Alok Bhaumik.
Thank you, Professor Tandon. May I now request our president to give this citation to late Mr. Mahendra Raj. On behalf of Mr. Mahendra Raj, Mr. Rohit Raj will be accepting it. May I request the president to kindly do the honors.
Thank you, Alok. It is my honor to present this Lifetime Achievement Award to legendary structural engineer, Mr. Mahendra Raj. I am sure his rich legacy will continue to inspire the entire structural engineering fraternity. I request Rohit Raj to kindly accept this award.
Thank you, Mr. Mittal. Thank you, Professor Tandon, Mr. Alok Bhaumik, for honoring my father. This was always his, you are absolutely correct in saying this was his child, and all the associations he mentored and grew with as he sort of took a back step professionally. He engaged more and more in all the associations, and his heart was absolutely linked to each and every association, engineering associations that he worked for. And we are privileged to be here for you all to have invited us. I can see my sisters there, my brothers there, my brother-in-laws there. Thank you so much for including us in this ceremony. Thank you so much.
Thank you.
Thank you, Mr. Rohit, for your acceptance. And let us now proceed with the second part of our event today, which is the first Mahendra Raj Memorial Lecture. Ladies and gentlemen, this annual lecture has been instituted by the Indian Association of Structural Engineers in honor and memory of late Shri Mahendra Raj ji, who was the founder, as mentioned earlier by our president of this association and the legendary structural engineer. As I had mentioned earlier, this lecture was originally planned to be delivered by architect Balkrishna Doshi ji. However, as he is down with COVID and he is not able to make this presentation, Professor Mahesh Tandon will deliver this lecture. But before that, he has been kind enough to send a 15-minute video giving his tributes to this legendary structural engineer Mahendra Raj ji, which we will play first. And this will be followed by the memorial lecture by Professor Tandon. So before I start, I request our secretariat to play the video of architect Doshi. I have the proud privilege and pleasure in highlighting some of the numerous achievements of architect Balkrishna Doshi ji. Architect Balkrishna Doshi ji is an architect of international fame who hardly needs an introduction here. He has made his mark all over the world. He is unique because no architect living today has worked as long as him and as deeply about the spiritual dimensions of architecture as architect Balkrishna Doshi did. He is the recipient of several international and national awards. Architect Doshi has been a member of the jury of several international and national competitions, including the Indira Gandhi National Center for Arts Steering Committee of Aga Khan Award for Architecture and Pritzker Architecture Prize. In recognition of his distinguished contribution as a professional and as an academician, Architect Doshi was awarded the Royal Gold Medal 2022 by RIBA, made foreign honorary member of the American Academy of Arts, and later in 2021, he is the recipient of Padma Bhushan, Government of India 2020. The Pritzker Architecture Prize in 2018, a prize that is considered to be the equivalent of a Nobel in architecture. The Officer of the Order of Arts and Letters from France in 2011, Global Award for Lifetime Achievements for Sustainable Architecture from Institute of Francaise d'Architecture, Paris in 2007, Prime Minister's National Award for Excellence in Urban Planning and Design to 2000, Aga Khan Award for Architecture, that is 1993 to 1995, Gold Medal, Academy of Architecture of France in 1988. These are few of the awards that Professor, architect, educator, professor, and urbanist Balkrishna Doshi has. So, sincere thanks to architect Balkrishna Doshi ji for his very inspiring, motivating video, which we will play now. May I request Vikas to kindly play the video.
Talking about Raj is one of the most fascinating story of my life. How simple event, meeting in Bombay, having lunch with him when I had no idea who he was, neither he knew who I was. And the friendship continued and became as if that we belong to the same family, same clan, same life. It's not the incidences of professionals, but it is the affinity by which you work. Not necessarily because he came from USA, I came from Ahmedabad, and we met by chance. But can the chance ever grow and become such a close friendship that we almost felt like brothers, family members? I learned a lot from Raj, my advisor, my consultant, our family consultant. And it was not the structural engineer that I met him for the first time in Bombay, who was talking to me about structures, engineering, and technology. But it was really growing with what is appropriate, workable, graceful, and meaningful. So when he passed away recently, it was the most shocking for us, for me particularly. So today's occasion, when I am talking about Raj, I am talking about Raj as a person, as an individual, as somebody who was humane, somebody who was sensitive, and who was excellent in his professional work, impartial. What is right, he will do. What is appropriate, he will find. And what is most meaningful, he will rediscover. So structural engineering and architecture and practice, to me, are not the occasions. It is a lesson of learning that how does one look at things holistically. He was a complete engineer. a human being, a person who helped discover the innate qualities of a professional and found the right solution. Not knowing his abilities, I met him as an engineer in Bombay, trying to find a solution to my structures in Ahmedabad. And suddenly he was showing me the structure that he had done for a new building in Bombay, how he was trying to do an underground building and gradually creating blocks and creating a superstructure. What an amazing feat, and how wonderful he was. And that is really what fascinated me about Raj. Always finding solutions, appropriate solutions, giving patient time, hearing, and looking at structures sensitively, creatively, gracefully, and finding solutions. Whether it was Prabhabai Hall, whether it was Tagore Theatre, whether it was a building in Bombay, whether it was a factory, or whether it was a house that I designed for myself. He would be a patient person, listening carefully, and then saying, "अरे दोषी साहब, ऐसे तो नहीं होता है, थोड़ा तो सोचो." Then I would say, "विराज साहब, क्या बताऊं, मुझे तो कुछ समझ में नहीं आ रहा, उसीलिए तो मैं कह रहा हूं कि आपको तो समझ में आता ही नहीं." So this is how our conversations will continue. But in the end, it was like a marriage, a union, a creative challenge. So Raj was really a man of many personalities, man of splendor, many things. A professional who never talked about structure or obligations or commitments, but he looked at it holistically. So one of the most important things that I think of Raj is a holistic person, a person of vast repertoire, knowledge, wisdom, and he knew what nature is, he knew what building is, he knew what structure is. And that's what really Raj is. And over 50 years that we began to our careers together and continued together, we always went through explorations of discovering new buildings, new ideas, new thoughts, new structures, and ended up by doing things extremely simple, easy, and unusual. For him, architecture and engineering was plastic art. Fluidity was there in his blood. For him, concrete was not concrete, it was a malleable material which was fluid, and then that fluidity created what nature creates: a structure, a support system, and configuration which is very graceful. Always graceful, always beautiful, always obvious. There was a flow in his structure. There was grace in his structure. There was plasticity in his structure. And there was that intangible proportions in his structure, which were the hallmark of Raj. There, I have never in my life, with all the buildings that I have seen, in fact, in difficult situations, I never found Raja structures looking inappropriate. They looked like making out of nature. Folded plates, flowering roofs, undulating shapes, and then a large variety of graceful relationships. It is like blossoming. So working with Raj was always creative. Because I knew that as an architect I have my limitations. But as an engineer, Raj would go beyond. He knew how nature behaved. He knew how structural engineering behaved. And he knew how grace behaved. And that is what Raj is. Though he was a structural engineer, he was a humanist. Inherently in his spirit, there was a flow of life, blossoming, always finding grace. Any engineering project that was available to him or by anybody that I know, Raj always talked about grace. Raj talked about harmony. So it was really like an advisor to me. So Raj to me often became my advisor. Elder brother, professional guru, and a structural engineer, consultant, all in one. That is to me Raj. Never I have seen him faltering in his work. Never I have seen him accepting something which is not so graceful. Raj is grace. Raj is an engineer of a very high order. Like we talk of Nervi, we talk of Raj. Everything has to be graceful. Everything has to be beautiful. Everything must flow in a certain way. That plasticity that we talk of, Raj was there. There was always this whole idea that how can you span and create lightness, create the flow which becomes natural. And that is how created those folded plates in Ahmedabad. Tagore Theatre would never have been like that. But because of Raj, Tagore Theatre has become what the theatre is. There is no heavy structure. The folded plates fold together, gracefully go up and come down. And then the auditorium inside is like a floating place, completely open. And the whole building is within a building. So he was also an architect, a designer who knew what to do and how to create dialogue between space and form and structure and movement. He always looked at it. For example, the Tagore Theatre, where I had made that apron in the beginning, I still remember those days. When that apron came, he said, "Doshi साहब ये क्या कर रहे हो आप? ये बिल्डिंग को आपको आगे ऐसा वॉल करके लाना है तो it should look like an apron which comes as if that you want to discover the inside." So he was talking as a plastician. So Raj was like this. Or when I did the house, or when I did small buildings, always the same question. इसमें से कैसे अच्छा बनाना है? So for me, Raj was not an engineer only, but he was a super gardener. Super gardener where nature, structure, form, connection, spaces, articulation, all went together and they all made into a symphony. and it was graceful, as if most obvious. So, Raj is to me not only a humanist, not only a friend, not only a family member, but he to me was a teacher. He was a wizard in engineering and a super gardener. So I would say that to me, Raj was a great gardener who always created blossoms, flowering and making everything feel light. His structures, his places, his relationships had no weight. That was also his nature. So in the end, I just want to say that Raj was as light, as graceful, as gentle, as beautiful as he was in his career, in his handling structure, as well as in his dealings in life with every relationship. So for me, Raj cannot be described only as a structural engineer. So all his structures that we did together, they have not had carrying heavy weight from top down, but they were blossoming as if that they were rising from below. And so Raj was like that till the end, till the last day. And I can only say that he was so touching in the end that with all his pain, with all his physical problems, he never expressed that pain. He accepted it gracefully, quietly, silently. And today I wish wherever he is, he has remained the gardener and he has blossomed the gardens all around him with fragrance.
What a tribute to this great legendary figure.
Talking about
Yeah, okay. So a great tribute to our Mahendra ji, and that too coming from a genius and eminent architect of the stature of Balkrishna Doshi ji. I think it's a great moment and it's a very proud moment for Indian Association of Structural Engineers, which has been blossomed and garnered by Mahendra ji. I I record my sincere thanks to architect Balkrishna Doshi ji for this. Despite the fact that he was suffering from COVID, he could spare time and recorded this video. I'm really thankful. I wish him a speedy recovery. And as our president mentioned, we will try and organize a special lecture from architect Doshi once he recovers fully. We now move on to the next part of this second event, which is the first Mahendra Raj Memorial Lecture. The guest speaker, Professor Mahesh Tandon, will be speaking on the topic of tall building innovations. I have already introduced Professor Mahesh Tandon, though he hardly requires an introduction in this August gathering. May I now invite Professor Mahesh Tandon to deliver the first Mahendra Raj Memorial Lecture. Professor Tandon, please.
Thank you, Mr. Bhaumik. I'm just trying to get this thing organized because the.
Are you able to share your?
Yeah, that's what I've been trying. Let's see if I succeed. Let me see. Are you able to see
Yes.
something on the screen?
Yes, sir. We are
Success.
seeing your PPT, but can you put it in presentation mode, please?
Yeah.
Yeah. Great.
Okay. So it was very touching to hear architect Doshi to talk about Mahendra Raj. And nowadays, when I start talking about him, I get emotional. So with your permission, I'm going to concentrate only on the presentation. And the rest of it we can discuss later. So this is my friend, Mahendra Raj, and I have assembled a special lecture on tall building innovations, which I think was part of his many repertoire that he had. These are some of the buildings that he designed. And I could fit all of them in 2 slides so that you get an idea of some of the structures that he was involved in. So about tall buildings, the Council for Tall Buildings and Urban Habitat have a classification based on height. 50 meters means tall, 300 meters means super tall, and 600 meters means mega tall. In 1890, buildings over 10 stories were considered tall, and they didn't have any further classifications. An Indian code, IS 16700, was published in 2017 on concrete tall buildings, and it covered a range between 50 to 250 meters. 70% of the world's projected 9 billion population will be living in urban areas by the year 2050. So we really have no alternative but to go in for tall structures which can house a lot of populations. And I will, of course, show you what the latest thinking is on the subject, but let's go further. There are certain milestones in tall buildings which we must recognize. The first was the inventor of the elevator, Elisha Otis, 1850. The architects and structural engineers need to be recognized for the first major tall buildings, that is the Empire State Building, which held the world record for 40 odd years. And you have the name of the architects and structural engineers on the left hand side. Then in 1957, the architect Frank Lloyd Wright was the first to think of a mile-high building. The structural engineer who in 1970 developed structural systems which are suited to very tall buildings was Fazlur Khan, and he was in the company called Skidmore, Owings and Merrill. But we know this company basically because of Fazlur Khan's contributions. There is another part of the structural systems which was built, which was one must recognize in recent times, because some of the buildings, like when you think of Burj Khalifa, that is not Fazlur Khan's systems. That is the structural engineers were William Baker and of course Thornton Tomasetti. These are the two people who did the structural engineering work, and the architect was Adrian Smith in both the recent buildings which we will talk about. Elisha Otis, here he is demonstrating at the New York World Fair in 1854 that a steam-powered roped elevators with toothed guides rails can go up and down, and it is equipped with a safety device to prevent it from falling, because people always thought in those days that perhaps it's all right to go up and down, but is it safe? So he demonstrated it in the New York World's Fair, which you see here, a picture which is taken maybe more than 100 years ago, but it is there. So he demonstrated that it is safe. And this was the start of the tall building revolution in the world, because without these type of gadgets or without these type of equipments, you could not build tall buildings. The Empire State Building is always a pleasure to talk about it, because it had 102 stories and it was built in 1 year, a little over a year. And the speed of construction was 4.5 floors per week. It is something which was done in 1930. And I think even now it may be difficult to equal this type of a speed of construction. And even in those days, that I'm talking about 1931, the president of USA, Herbert Hoover, he turned on the building's lights officially, opening it by pressing a button in Washington. So it's not only these days, but even in those days, people had ideas as to how to do it. This, what you are seeing now, are 3 buildings which I wanted to show. The present record is the Burj Dubai, which you see on the right side. It's the present record with 828 meters being the height. The under construction building of Jeddah Tower in Saudi Arabia, it was supposed to be a kilometer high, but it has come to a halt somewhere in between because of financial and other problems which Saudi Arabia went through. And now we don't know when it is going to be completed. On the left hand side, you see the concept of Frank Lloyd Wright, the architect, and you can see what a similarity there is of whatever his concept was and what the tall buildings look like, the tallest of them all look like today. So although he was an architect, but with great imagination, and he could predict what the buildings would be like. Especially if you can see, it is tapering. The building is tapering from bottom to top, and of course, it has got a number of um, uh, I would say not perforations, but a number of uh, indentations, etc., on the outside. We will see what the reason for this is, but he could imagine that if you want to build a tall building, it cannot be just a smooth a kind of a structure. It has to have these type of things. And you can see the Burj Khalifa, Dubai. That building is also something similar. It doesn't go just like a cylindrical shape or a conical shape. It has got a lot of uh, ups and downs as you go up. And this was the something which could be imagined by an architect. And that is, I think, something to be something which is praiseworthy. Here you can see Frank Lloyd Wright at work, and you can see him putting the finishing touches of his proposal of the mile-high building. In those days, there were no computers, so there was no easy way in which you could do it. You had to have a very long sheet of paper, as you can see, and he is drawing on it. And of course, one of the things that he mentioned, which is truly very touching, he said there is no true understanding of any art without some knowledge of its philosophy. So this was, if you read this his book, A Testament, which was published in 1957, I think you can get all the details of this building and many more of Frank Lloyd Wright. He is considered to be the greatest architect USA has ever produced. So, if, as things stand today, you can see the right-hand side, the Burj Dubai, where it has reached. And at the bottom, you can see what is the additional height that each time a building is made, how much is added to its height. So you have 36 meters, 25 meters, 10 meters, 57 meters. And finally, you have 299 meters from the earlier record, which is actually the Taipei 101. Fascinating building, but you can see the way the height has grown. Burj Dubai, part of the secret lies in the fact that it has a concrete base up to about this much height, and then finally the upper part is made in structural steel frame. So this last part was what could enable the building to be so high. If you look at some of the statistics, it is founded on 3.7 meter thick raft supported on board piles 1.5 meter in diameter, extending approximately 50 meters below the base of the raft. So if you see the foundation itself, it will give you an idea as to what was involved. This is the Kingdom Tower, which is supposed to be higher than 1 kilometer. On the left-hand side, you can see the structural framework which was adopted. And they had long shear walls and of course cross walls also, because the long shear walls would not be stable without them. So this is basically the concept, the structural concept that was made for the Kingdom Tower, and it is very similar to the one which was adopted for the Burj Dubai. On the right hand side, you can see uh, the wind tunnel test, because all tall buildings, once they reach a certain height, it is better to do uh, the wind tunnel test as is shown here. And here you can see a turntable, so that although the wind tunnel gives you uh, wind blows only from one direction, but you can make the building rotate so that you can find out what are the effects uh, from various directions. The last photograph on this slide, you can see this is where it has stopped at the moment. I think it is something like 600 meters, but I'm not sure of the exact height. Let's talk about Fazlur Khan. On 3rd April 2017, there was a Google Doodle which honors Fazlur Khan, a structural engineer who helped design some of America's most iconic skyscrapers. As importantly, Khan's innovative tube system made it cheaper, safer, and easier to build super tall structures, enabling the look and density of our cities today. I think the closest in our country who comes to Fazlur Khan is Mahendra Raj. He was really the Fazlur Khan of India, but his creations were not limited to just tall buildings, but any kind of structure. Now, Fazlur Khan ushered in a renaissance in skyscraper construction during the second half of the 20th century by introducing the tube concept of structure. Here you can see the structure is actually outside the building, on the outside facade. Nobody before him had really thought of that the structure can be put outside on the facade. Here you can see both concrete and steel applications where the structure is on the outer facade. Fazlur Khan developed many structural systems for both steel and concrete. And you can see some of them here. And this is Skidmore, Owings and Merrill. I think the tradition set by Fazlur Khan is still continuing, and they are still designing the tall buildings of today. Some of the things which we take for granted is the behavior of frames and walls, shear walls rather. So it is a simple concept but extraordinary.
I think we have lost Professor Tanda's voice. Maybe his signal is weak. Tandon Saab, we are not able to hear you. I think we may have to wait for a couple of minutes for him to come back. Apologies for this goof up, I think not in our hands.
Maybe Vikas can call and
If you can call him, yes.
Yeah.
Yes, ma'am. Yes, I'm calling. I am calling you.
I think he has joined back.
Oh, how much have you have I been talking to myself? And how many slides have gone by? I don't know.
No, you were on the slide, you were explaining the
Okay,
difference
okay.
of the behavior of
I
the
think-
frame and the wall, shear wall. So that was a slide you were talking about.
If you can just reopen, we can tell you exactly where we lost your signal.
If you can you hear me?
Yes, yes.
Okay. So you can see the interacting forces.
Yeah,
As a
if
matter
you
of-
kindly share your presentation. It's not shared as now.
Oof.
The challenges of technology.
Yeah.
Let me see where the share button is, because that is gone.
No, I think you can stop sharing and then reshare.
Okay.
That may be a quicker way.
Oh. Zoom webinar, I can see very clearly. And
Yeah, it's
can
coming.
it's come?
Yes, it has come. Just you can put it in the. There is
Yes,
something
I'll
in
go
the
to the,
presentation mode. Yeah.
and of course one must go to the slide. I don't want to repeat what you have already seen.
Yeah, I think.
Sir, he has to go near to 9th or 10th slide, sir. Please tell him.
You have to go to
9th slide or 10th slide, sir, please.
9th or 10th.
Yes, sir.
Ninth or 10th would be somewhere here. Are you sure you?
If you
Sure. Yeah, yes,
No,
sir.
this-
Sorry. You can please come to 13th, sir, please.
Yeah,
13th
I
one.
think
yeah, we have
12th
gone through this.
we have gone
Yes.
through this. That's what I thought. Shear wall
Okay.
frame interaction, or this you have seen?
Maybe 15, the one before.
Okay.
Yeah, I think you can start from here. I mean, maybe a bit of overlap, but you can start from here.
Okay. This is Fazlur Khan,
Yes.
and on 3rd April 2017, they honored Fazlur Khan, a structural engineer who helped design some of America's most iconic.
टंडन साहब इसको
skyscraper.
presentation mode में कर दीजिए. This is now not in presentation mode. Yeah. Oh, we got something else now. Yeah. Okay. I think we were here.
You are here. Okay. So Fazlur Khan was the first person who thought of putting the structure outside on the facade of the building, as you can see here, instead of putting it inside and cluttering up the whole area with columns. Here you can see both steel and concrete examples where the structure is on the outer skin of the building. Many structural systems which are suited to different heights of the buildings he had invented. And as you can see here, this is still being like IS Structi has Mr. Mahendra Raj in its mind when we think of buildings. The Skidmore, Owings, and Merrill. They think of Fazlur Khan when it comes to tall buildings. So this is a simple but extraordinary finding by a structural engineer called Fazlur Khan. If you have a frame by itself, it behaves like what is shown in diagram A. If you have only a shear wall, it behaves as is shown in B. So what Fazlur Khan decided to do was to join the two together so that at the top it would be really coming together of the two types of structure, that means shear wall and frame, and at the bottom again it would come together. This is what it looked like, his conception. And today we take it for granted that everybody knows about shear wall frame interaction, but let us pay homage to the person who first thought of it. One of his earliest buildings in concrete was where he put a 8-meter deep transfer beam right at the bottom. But this is not the only thing that works as a structure. He has got this outer framework which acts as a structure on the outer periphery, and he also has a tube in the center, or rather the core of the building, that also. So there is a core and which is the shear wall, as well as the frame which is on the outer surface, which go together. They work together. Here you can see another building, which is one of his earlier buildings in concrete, 217 meters high. And what was the great thing about putting the structure outside? Can you see the slide? Hello?
Yes, we can. We can, Professor Tandon.
Okay, and you can hear me?
Yes, of course.
Yes.
Okay, so here you can see just a rectangular building where in the central part there is the utilities which go up and the lifts. That space is occupied by these items, but there is no column anywhere. Columns, or rather the whole structure, is located only on the outer periphery of the building. So you could have no column-free space, which the architects are so fond of, and they keep talking about they don't like columns at all. So I think this was made for architects, basically. Now, just talking about, when we talk about tall buildings, we have to talk about not only the gravity load, but wind and earthquake. So we'll discuss a little bit about that. If you have just that means that there is no wind or earthquake, you would have what is shown in this line. That would be the guiding line, which tells you the number of stories and the average weight of steel in pounds per square feet. This is, I have taken exactly from what Fazlur Khan had made this diagram, that how much is the premium for height that you are paying for going high. For tall buildings, you can have 25 pounds per square feet if there was no wind or earthquake, and you can also have 65 pounds per square feet, which is 2.5 times that, if you have the wind and earthquake also to be taken into account. So this we must understand that why the structures of tall buildings are always more expensive, because you are paying a premium for height. The main issues of tall buildings are, one is the structural strength and stiffness for lateral forces, evacuation. How do people evacuate from the building? I think after the World Trade Center towers, I think everybody is worried about evacuation. There is also the question of vertical transportation, which the origin was done by Mr. Otis, that you have lifts going up and down. Vertical distribution of utilities is another thing. That how do you how do you send water, how do you do drainage, and so many other things. Vertical building movement is the other problem. There is, if you have such a tall building and such a big height, the building actually shortens because of elastic deformations. Another problem of during construction, setting out and verticality. The building actually sways even during construction, and how to keep the setting out and the verticality in position is another issue which tall buildings have. The other thing is about hoisting of materials, equipments, personnel, which is again a big issue which has to be resolved beforehand. How you're going to transport concrete from bottom to something like 600 meters high, you must plan that. So the slenderness of the building is another big issue, because as you will see, there is a comfort level that people must have who are living in the upper floors. So slenderness ratio is height by whatever is the width. In this case, the shorter dimension, the B, so it's Burj is h by 10. So that is quite remarkable, because normally you try to do h by 6 or h by 8. This is what we try to aim at, but Burj, of course, is something exceptional. And our code also 16700 also permits h by 10 in certain conditions. The deflection at the top, h by 500, that is the limit. Interstory drift for wind and earthquake is different. For wind it is h by 500, and for interstory drift it is h by 250. This is the drift between two consecutive floors. How to find that out is also there, because this all these play a important role in the comfort level of the people who are staying there. So you can see peak ground acceleration is the other major issue. For residential buildings, it is more stringent as compared to office buildings. Now, if you see the wind comes from one direction, but there can be three effects on it, on the building itself, the response. You can have a long wind response, you can have a crosswind, and you can have a torsion. So all these have to be taken into account. And another issue is the terrain category. Like, for example, if you are in urban areas, you already have a number of buildings. So there the wind action is different. This Vg, what you see, is the gradient height above which the wind becomes more or less a constant speed. So as you keep on going down, the wind speed also comes down depending on the terrain categories. So that is why that you have to model perhaps in the wind tunnel, which is the best solution till today, to find out how the behavior is, because these buildings which are already existing, they have to be modeled also to find out what is the effect of the new building which you are going to construct. The other thing is about the interference effects. If you have two buildings which are more or less similar, then the effect can be quite drastic, one on the other. So that also is something that it's the wind tunnel which will tell you, rather than there are other ways of finding out, like the CFD, computational fluid dynamics. People are doing all that in computers, but at the moment, I think the most reliable thing is to go for a wind tunnel. Wind tunnel, here's a wind tunnel. The National Wind Tunnel Facility at IIT Kanpur, which we had the pleasure and the privilege to design for them. You can see that it is a closed circuit wind tunnel, and you can also see the turntable, so that you can rotate the building itself, because the wind will come only from one direction in the wind tunnel. So you can find out the effects. Now, talking about earthquakes, what is dangerous is the resonance of the resonance of the building and the whatever is below, the soil or rock. If you have hard soil or rock, the dominant period of the earth is about 0.5 seconds. But if you have a soft sediment like we normally have, then of course it is 2.5 seconds. So the buildings, if you don't want the building to resonate with the ground, then you should be away from these frequencies. As a matter of fact, people often think that tall buildings are more dangerous than short buildings in earthquake. That is not correct. If you design it properly, the tall buildings are actually safer. Okay, this doesn't work. Of course, there are other ways in which the effects can be reduced, either by base isolation or by just 1 second. Anyway, if you have a base isolated building, that is the other way in which you can reduce these effects which are due to wind and earthquake. I wish I could show you a building which is shaking, but I think we'll have to miss that. And there's another thing which is dampers. Dampers means that if you see this Taipei 101, which held the world record before Burj Dubai, there is this big yellow 700-ton steel ball at the top.
Tanan, I would like to go back to the slideshow. Thank you.
So this steel ball that you see, it is hung from the top, and it moves in the opposite direction to which the building is moving. So it is actually damping the vibrations of which may be due to earthquake or wind. And it has already, as you can see here, withstood the wind, the design wind speed, and the earthquake, which you can see on the right hand side. So let us go and see whether this thing works. The blue line is the building, and this yellow ball that you see, this is the steel ball of 700 tons, which is moving opposite side, opposite to the direction in which the building is vibrating. So this is how we are able to reduce the effects of both earthquake and wind due to this. Now, I wanted to talk about the Kingdom Tower, which is supposed to be greater than 1 kilometer high. At least it was supposed to be. So what are the main issues? The technical challenges are that you have to pump at such high levels that you have to have a pump which can take about 400 bars as pressure. Only then you will be able to pump the concrete to the heights that you want in this building. Fire risk is another big issue, especially after the World Trade Center issues. Everybody is thinking of the fire risk and evacuation. There are actually no codes available for evacuation. But for this building, what they thought was that if you take about 2/3 of the time, half to 2/3 of the time, which took the World Trade Center to collapse, that much time everybody should have to go outside the building. So this has become more or less the norm for tall buildings, which is, which is now done everywhere. And just to tell you, the financial things are one of the reasons why this building has come to a halt, I think, is that tall buildings do not generate profits. Money comes from property development from surrounding areas. If you go to Burj Dubai and see, it really there is so much of development around it, and that is where they are earning the money from, not from the rents that they get from the occupants or the tenants. Now, coming towards the end of this, there is an American architect, Eugene Sui, Chinese American. He thought of the Ultima Tower, which is 2 miles high. And if you can see the shape of the building, and if you can see Burj Dubai in comparison, here, you can imagine how tall this is. And according to this architect, you can house the whole San Francisco city in this tower. Of course, the cost will be about $3 billion. But this is what the new thinking is coming, that you can have taller and taller and taller buildings. Okay, thank you very much for your kind attention.
Thank you, Professor Tandon, for your very enlightening and insightful presentation as always. And really thankful to you for raising to the occasion at such a short notice. Only in the morning today we requested Professor Tandon to deliver this lecture, and he sort of came out with this fascinating presentation. Thank you, sir. I now request our president to give a vote of thanks to Professor Tandon for this memorial lecture.
Thank you, Professor Tandon, for delivering excellent lecture on tall buildings. And you trace the entire history of the tall buildings and how the structural systems for tall buildings evolved over a period of time. And you also explained how what will be the behavior of these structural systems under various type of loadings. So overall, it was very interesting and fascinating presentation. And I thank you for delivering this first Mahendra Memorial lecture. That too on a very short notice. I thank you so much on the behalf of Indian Association of Structural Engineers. And I would like to present you a memento as a token of appreciation from IE Structures. Please accept this.
Thank you, Mr. Mittal. I must say that this is also done in a very short time.
Yeah. Yes.
But thank you very much. And it was a pleasure to talk about tall buildings, which is always
Yes.
fascinating.
Thank you.
Thank you. Thank you so much, sir.
Okay, so thank you, Manoj, and thank you, Professor Tandon, once again. We now move forward to the next event of the day, that is the annual award ceremony 2021. And it is my proud privilege to welcome Professor Prem Krishna, Chairman of the Awards Committee, and request him to conduct this session and do the honors, please. Professor Prem Krishna, as many of us would know, is a pillar in our industry with very many accomplishments. One of his major contributions to the benefit of this profession is his work in the field of wind engineering. So I now invite Professor Prem Krishna to kindly conduct this session and do the honors, please.
Thank you, Alok, for your kind introduction and for handing the baton over to me for the final round of the program. Also, good evening to all present on the call. I'm sure you will agree that this has been a very special event where we are remembering and celebrating a very special person, the iconic and much revered Mahendra ji, and a very warm and affectionate person that he was. Of course, first we have had the presentation of the Special Lifetime Achievement Award, which, as Mr. Bhaumik did say, we had hoped to give it to him in person, but that couldn't happen. So we are happy that his son, Mr. Rohit Raj, has accepted this present on his behalf. And then, of course, the very fascinating memorial message from the eminent architect, Shri Doshi. One could see that what he was saying was coming from his heart all the time. Such was the close relationship, apparently, between him and Mr. Raj. And then, of course, the redoubtable, brilliant lecture from Professor Tandon. I think short notice, particularly, only he could do it. Of course, his lectures are always very interesting and informative, but to do it at such short notice and put all this information together, I think he's one of the few who can do that. So we appreciate his lecture. So it has been a very rich fair so far, though a little emotionally touching. In fact, Even the next part of the program, the annual awards ceremony, is something which is a result of the part of vision that Mr. Mahendra ji had. In fact, 3 years ago, he suggested that the IAS Shakti should set up these awards, and we followed up his advice, and the framework could be made ready to run 2 cycles so far, 2020 and 2021. 2021, we are just about to complete. The committee, the awards committee, I must introduce my colleagues here. You see it on the picture. Mr. Amitabh Ghoshal, very eminent structural engineer, an honorary fellow of the IAS Shakti, and immediate past president of CEAI, and a senior octogenarian, still very actively serving the profession. Then we have another senior professor, Professor Dulal Golder. He is a governing council member of IAS Shakti, former principal, Delhi College of Engineering. Professor Karisadapa is a fellow of IAS Shakti and currently Vice Chancellor, Vishwesvaraya Technological University, headquartered at Belgavi in Karnataka. And he has a huge number of colleges and students to take care of. But besides that, despite that, he could find the time for our awards committee work. Then Dr. Vishalakshi, who you know well, is the honorary secretary of IAS Shakti. He's also a professor at Mahendra University. And I must say that because of the diligent efforts of all the members in this committee, and with very willing and immaculate support that came from the office of IAS Shakti, Mr. Vikas Verma and Ms. Namika, it is with that we could complete this task of deciding about the awards for the 2021 cycle in time to be having this ceremony today. We have been trying to reach far and wide to receive nominations for the various categories of awards, which are Outstanding Structure, Outstanding Structural Engineer, Outstanding Woman Structural Engineer, Promising Young Structural Engineer, and an award for the Outstanding Master's Thesis in Dealing with Structural Engineering. And I am happy to say, and in fact, Mr. Mittal already has mentioned that compared to 2020, our nominations were more, not only in number, but also richer in quality. This augurs well for this award, and I think it will grow in years to come. The entire process, particularly, I think, forced by COVID, was online. The nominations were received online. They were evaluated by the awards committee members, also online independently of each other. And then we would put these evaluations together in a meeting, which was also online, and decide about the awardee. This process, of course, was repeated sequentially for all the categories. Very interestingly, in the category for Outstanding Woman Structural Engineer Award, the marking came so close that it was amazing. Out of a total of 500 marks, each committee member evaluating out of 100, 3 nominees got marks as 401, 399, and 398. And the awards committee very happily agreed that these 3 nominees should get the Outstanding Woman Structural Engineer Award. As we now commence the process of presenting the awards, there are 2 points that I wish to share. Each awardee is receiving, apart from a memento and a certificate, a copy of the book about the works of Shri Mahendra Raj. Also, there is a time slot of about 3 minutes for each awardee to respond following the presentation of the award. I would like to remind all of you. Hello. Can you hear me?
Yes, yes, sir.
Yeah. But I do, wish to remind our outstanding structural engineers that structural engineering is a discipline with exactness. So I will request them not to cross the line of 3 minutes when they give us our comments or suggestions or whatever they would like to say. With this now, I would like to begin by announcing the first award. And the first award is for the most outstanding structure in the category of buildings. And the award goes to Mrs. Larsen and Toubro for the beg your pardon, for the sports stadium in Ahmedabad. Mr. R. Eswaran is going to receive the award on behalf of L&T. And I'll request Mr. Vinay Gupta to kindly read the citation for the award. Of course, you all know Mr. Vinay Gupta is the Vice President of ISTRUCT Northern Region and a very eminent structural engineer. Vinay, may I request you to read the citation for the L&T award?
Yes, sir. It's my pleasure to go through the citation and apprise everybody else. Mr. Manoj, are you supposed to display the citation or should I just read it and that's enough?
No, it can be displayed.
Right, it is displayed now.
It is displayed.
Yeah, so congratulations, L&T. Congratulations, Mr. R. Eswaran. The award that is being given to you is on this famous Narendra Modi Stadium in Gujarat. The stadium is located at Motera, Ahmedabad, on the banks of Sabarmati River. It is the largest cricket stadium in the world. Built on a total plot area of 63 acres, the stadium complex includes various supporting facilities for conducting the game safely and comfortably apart from the playing arena seats for spectators. The arrangement of the podium, the supporting Y columns, and the unique lighting system all put together provide a new experience to the spectators. Innovative, unique features and functional efficiency has been achieved through appropriate integration of architecture, structure, and services. These are all siblings, let's call it, for success of a building. The roof along with the roof supporting V columns creates a dynamic spin effect on the facade. The stadium is provided with a spoke wheel concept. I hope you all know spoke wheel concept. Roof comprising of fully locked radial cables connected to inner tension ring cable and outer compression ring and covered with PTFE fabric. Due to repetitive nature of the structural elements of the stadium, precast system was chosen for faster construction and better quality. More than 50% of the entire stadium is made out of precast elements, numbering about 15,000 numbers. The heaviest asymmetric system, weighing 235 tons and 35 meters in length, is adopted in the structure. It necessitated to develop innovative structural design principles for handling the elements during various stages of erection. The architectural design was developed by Populus from Australia, and the detailed architectural and structural design was done by the in-house team of L&T Construction. The stadium received gold rating under IGBC Green New Building Rating System from Indian Green Building Council, that's IGBC, by adopting latest technologies for providing these services, keeping in view the need of sustainability. So in view of this outstanding accomplishment of creating a giant sport cum entertainment complex with high level of engineering excellence, Indian Association of Structural Engineers considers itself privileged to present the Outstanding Structure Award in Buildings category of the year 2021 to L&T Construction, wishing them continued success in creating excellence in major structures. So I think with these words, we have all understood how excellent the structure is and what world record it has created. May I request Mr. Eswaran to take 2-3 minutes and say something about how you feel about this award, this association, IA Structure,
Yes,
and if
yes,
anyone
sir.
immensely contributed towards the success of this to help you out, please.
Yes, sir. Thank you, sir. I want to confirm that whether I am audible and are
Yes,
able to
you are
see me,
audible.
sir.
Yes, yes, you are audible. Loud and
Yes.
clear.
Yes.
Please
Thank
go
you,
ahead.
sir. Thank you very much. I can tell you that I got very good energy after 2.5 hours that proposed Horlicks, everything has been given to me. Like, as a senior person, eminent person, and I have seen a lot of very good presentations. And with this energy, and also the energy I worked before, also with that energy, I just start my speech. Respected President and association members of Indian Association Structural Engineers, panelists, and participants. Good evening to all of you. It gives very immense pressure and pleasure to us to project or to present to be here in this award-winning ceremony, because you all know that it gives a lot of motivation and for getting this sort of recognition, for remembering our great work, and also to do better in this. And basically, I'm a structural engineer. I joined in this company 27 years before, after passing out my ME Structural Engineering from PSD College of Technology. This company provides me a lot of opportunity to the other engineers. And I just want to highlight, which has been, other than the points which has been highlighted here, we as a structural engineer, not only for look for the structure, we also look for other aspect about safety, sustainability, and also modern usage of technology. For the safety aspect, we use the precast because of controlled concrete. Second is in the sustainability aspect, we also look for getting the green ratings, whatever it is possible. In modernization of technology aspect, we are using the BIM technology and all the other technology for using the erection, etc. The element which we have seen, the Y element, is the element which is a 250 element weight capacity. It was modeled in prototype and checked for its erection purpose. This stadium has won the other awards, which we got ACCE, Association of Civil Engineers, Consulting Civil Engineers Award for excellent use of steel tubes. And also we got outstanding award from ACI. We also has got nominated from FIB structure unit, outstanding structure award. Therefore, with these, and I like to thank the panel members, also jury member, for selecting this. It is giving the great opportunity to us to work further and to enrich further in this field. Thank you very much. Thank you very much once again to all of you.
Vinay sir, please unmute yourself.
Sorry. Thank you so much, Mr. Eswaran. May I now invite our president, Mr. Manoj Mittal, to give this award away to Mr. Eswaran.
Thank you, Vinay. Congratulations, Mr. R. Ishwaran, for winning this outstanding structures award for L&T. And I remember that Narendra, some time back, we had a webinar on this structure, which was organized by our association. So it's really, I'm very happy to present this award to you and L&T. And I hope L&T will continue producing outstanding structures in future as well. Please accept this award on behalf of IS Structuring.
Thank you, sir. I can tell you that it is very privileged to us, to my design team, and also to execution team, sir. Thank you very much.
Thank you.
Thank you, Mr. Iswaran, and congratulations. I might add that last year also L&T bagged the award for outstanding structure. In the cycle 2020 also L&T bagged the award.
The same is the case in ICI as well.
Okay. Okay. It's my pleasure now to announce the award for the outstanding structure other than buildings. And in this category, Professor S. Arul Jayachandran is going to receive the award for his contributions to a very outstanding structure, the Phoenix Memorial in Chennai, in India. May I request again Mr. Vinay Gupta to kindly read the citation.
Yes, sir, my privilege. And of course, we know the humble person, Professor Arul Jayachandran, he can only do wonders out of his humbleness and the softness. So it's again a proud privilege for me to read out the citation of the work that he has done. The iconic Phoenix Memorial, that's a structure for which the award is being given, in a non-building category. It's a grand monument for the former Chief Minister of Tamil Nadu, that is Purachi Thalavi Selvi Jayalalitha, at Marina Beach, Chennai, modeled as a mythical phoenix bird. The rising phoenix-shaped concrete structure is envisioned as a pair of wings rising from her final resting place. The wingspan of the structure is 42 meters. The height of the arch is 21 meters, and the height at the tip of the wing is around 9 meters. The memorial is a pair of tapered cylindrical shells whose connections give an illusion as if they are supported on the non-planar tapering arches. The ribs joining the shell and the arch are made up of hollow steel members, and Professor Arul Jayachandran is a steel expert that we know. The shell structure is tied at the bottom of the arch like a cantilever. The superstructure is modeled and analyzed as in SAP 2000 FEM software, duly accounted for the pile and the pile cap. Duly accounting for pile and pile cap, the cylindrical wings are assigned as thick shell elements and the arches as beam elements. The wings do not have uniform thickness and the elements are tapering towards the arch. The memorial is a heavy RCC and steel structure, and the major contribution of stresses is coming from its own self-weight. The Phoenix Memorial is a complex and one of its kind structure conceived by Murali architects and built by Messrs. Krishnamurthy and Associates with support from RMD Quick Formwork and ICOMAT. The overall construction coordination was done by the Tamil Nadu PWD team led by Mr. Ayura Thasu. Well, let me just see. Ayura Tharasu Rajashekaran SE, Superintending Engineer. The structural design posed unique challenge, and the same was overcome by the design by IIT Madras under the leadership of Professor S. Arul Jayachandran. So to honor this outstanding accomplishment, Indian Association of Structural Engineers considers themselves privileged to present the Outstanding Structure of the Year Other Than Buildings Award to Professor S. Arul Jayachandran, Department of Civil Engineering, IIT Madras, for the excellent structural design, and wishing him continued success in creating excellence in major structure. Right, so I'm sure you heard a lot about this. Now let me request Mr. Manoj Mittal, our president, to first formally present this award before I request Professor Jayachandran to say a few words about this, how he feels about it. You are a professor yourself, but he has immensely contributed towards your success, towards this award, who helped you out, or whatever you want to say. But before that, the award must be given to you. So Mr. Manoj Mittal, please.
Thank you, Vinay. Congratulations, Professor S. Arul Jayachandran, for winning Outstanding Structures Award in a non-building category. for Phoenix Memorial Marina Beach, Chennai. I am honored to present this award to you.
Thank you, sir. Thank you very much, sir.
So, sir, a few words by you, about 2-3
Yes,
minutes.
sir.
You can
Yes,
take
sir.
professors, nothing less than 2-3 hours works.
So am I audible, sir?
Yes, absolutely.
Yeah. So first of all, I thank Indian Association of Structural Engineers, the members of the executive committee, and especially the juries of the award. First of all, I pay my tributes to Sri Mahendra ji, whose vision has made all of us to come together today. And Professor Prem Krishna and Professor Tandon, they were big inspirations for me, even as a student. I haven't spoken to Professor Prem Krishna, but I walked with him about half a kilometer along with Professor Lakshmanan, and during one of his visits to SCRC, Mr. Manoj Matul, Alok ji, Hagde ji, Vinay ji, and Professor Jaya, good evening. And my congratulations to all other prize winners. I'm passionate about structural engineering because I've been working in the field for 25 years, solving industry problems. Designed about 500,000 ton of steel, but still I lived in obscurity. I always ask the question, am I worth the salt as a structural engineer? This award is really a motivation to me, and I will keep designing more structures in my lifetime, for sure. I was molded in two workshops. One is Structural Engineering Research Center, Chennai, and IIT Madras. I'm grateful for both institutions. One morning, the PWD chief engineer from Tamil Nadu walked into my room and asked me whether I could design this iconic Phoenix Memorial bird structure. And my answer was a spontaneous yes, and I enjoyed the journey thoroughly. Probably I want to imagine myself as Sir Ferguson, the famous coach of the Manchester United football team. I always want to get the best out of people, and my team players were Murali Architects, Krishnamurti Associate, the contractors, Marbag Infra Private Limited, who designed the design support for us. And they are in the front line, of course, and in the middle, RMD Quick, Formwork, and ICOMAT, the midfielders, and Mr. Ayiratharasu Rajasekharan, who is a superintending engineer of PWD as a deep defense. I'm sharing the award with all my team players. I thank Indian Association for Structural Engineers once more. My structural journey will be in high speed after this award. And thank you. And someday I will share the technical details of this structure. And I seek blessings from all the doyens of structural engineers in India. And I will continue to my teaching, research to the profession in the rest of my life. Thank you very much, sir.
Thank you, sir. Thank you.
Thank you very much for your remarks, Professor Arul Jayachandran. It's very nice to see you after quite a few years.
Thank you, sir. Yes.
And also very nice to see you get this award.
Thank you, sir.
Thank you, all the devotion that you have had to structural engineering.
Thank you, sir.
It's a very befitting award to you.
Thank you, sir.
I'm sure you'll design many more.
Thank you, sir. Yes, sir. Sure, sir. Thank you.
Thank you. The next award is for the Outstanding Structural Engineer 2021. And I have the pleasure to announce that the award goes to the redoubtable Mr. V.N. Hegde. May I request Dr. Shilpa Paul to kindly read the citation for Mr. Hegde. Dr. Shilpa Paul is a member of the Governing Council of the IA Structi and is a very dynamic young academic. Shilpa, please.
Thank you, sir. It's a pleasure duty of mine to read the Outstanding Structural Engineer of the Year's citation. Mr. V.N. Hegde, formerly CEO of STUP and formerly Executive Director of GEMIN, is currently a structural engineering consultant. He received his Bachelor's of Engineering in Civil degree in the year 1984 from Mysore University. He obtained a postgraduate diploma in construction management from National Institution of Construction Management and Research, formerly known as NIGMARC, in the year 1987. And he got the postgraduate diploma in Master in Administration Management from Jamanlal Bajaj Institute, Bombay University in the year 1994. Mr. Hegde has pursued the engineering profession since 1985, and with the expertise not only in the field of structural engineer design, but also deep knowledge of construction aspects, he has endeavored constantly to innovate and take its practice to greater heights through such contributions as upgradation of many important standards and actively engaging in several engineering associations and organizations. He was admitted to the prestigious fellowship of the NIAE, that is Indian National Academy of Engineers, in the year 2015. The list of challenging civil engineering structures in which Mr. Hegde has been involved is large design and construction of more than 70 long span major bridges, flyovers, and MRTS elevated structures, 260 minor bridges and culverts, including the iconic Signature Bridge in Delhi. The eminent work of Mr. Hegde was recognized by numerous honors and distinctions. Some noteworthy accolades include ACCE Somdutt Award 2006, 2008, 2019, CIDC Vishwakarma Award 2015, Construction Time Award 2018, IIBE prizes and awards in 2001, 2004, and Outstanding Concrete Structure Award for the year 2004 and 5. He has also been involved in the design of hydraulic structures like the aqueducts, sea and marine intakes, submarine tunnels, and design of IDCTS and NDCTS, and other structures, getting the ACCE L&T Endowment Award from the year 1998, 2000, 2001, and Birla Plus Endowment Award for the Outstanding Concrete Structure of Karnataka of the year 2005. In recognition of his accomplishments, the Indian Association of Structural Engineers is privileged to confer upon Mr. V.N. Hegde the Outstanding Structural Engineer Award 2021, wishing him great success and contribution towards excellence in structural engineering. With this, I request the President, I.S. Takti, to please confer the award to him. Mr. Hegde and Mr. Mittal, please.
Congratulations, Mr. Hegde, for being named as winner of Outstanding Structural Engineers Award. I am pleased to present you this award. Continue doing good work. Please accept this award.
Thank you, Mittal, and all the others who found me fit to be receiving these awards in the first place. And all of you know that normally I'm not at loss of words, but it's my experience. I've been receiving awards, and this, like giving a speech, award receiving speech, I find always it's most difficult task, because sometimes we'll have to talk about ourselves, like that becomes difficult. But I have to tell today that I consider myself to be very lucky and immensely honored, because I'm receiving this award on the occasion of a very, like I feel a divine moment where Mahendra Rajji was, given the Lifetime Achievement Award. And also I could hear many achievements of Mahendra Rajji during this this time. And I'm motivated, I can say once again, and it puts an additional onus on me now to come out with the works which deserves more and more awards. I am encouraged and motivated, and you will see that more attempts and the efforts being put for me going forward in the future. I once again thank you all, especially the jury, for finding me deserving this award. Thank you very much.
Thank you, Mr. Hegde, and congratulations. And I'm sure you have a line of awards, as you have in the past also. You've been getting many awards. So I'm sure you'll get many more and continue to contribute to structural engineering. Thank you very much.
Thank you.
The next category of awards is for the outstanding woman structural engineer. And as I had mentioned earlier, in this category, we found 3 outstanding women engineers who were very, very close to each other in the evaluation. And so therefore, all the 3 are going to be presented with this award. The first in this category is Professor K.P. Jaya. And I'll request Mr. Vinay Gupta to kindly read the citation for Professor Jaya.
Sure, sir. It's a pleasure for me. In fact, I'm going to meet her also in 2 weeks' time, and I guess you will also meet.
Yes.
Dr. K.P. Jaya, currently a professor of structural engineering and head of the Department of Civil Engineering at the Anna University, Chennai. She obtained her BTech degree in civil engineering in 1988 and an MTech structural engineering degree in 1992, both from Kerala University, and PhD from IIT Madras in 2000. After a brief stint of 4 years in the field, she entered a career in research and teaching. Dr. Jaya joined the SRM Institute of Science and Technology, Chennai, as assistant professor in 2002 and moved to Anna University in 2003, where she is still serving. Her research interests involve the subject areas of structural dynamics, earthquake engineering, reinforced concrete structures, precast structures, vibration control, wind engineering, soil structure interaction, and so on. She has so far guided 12 PhD students, with 8 continuing even now. Dr. Jaya has written 2 books, 2 book chapters, and 51 journals in papers, and has 2 patents. That's important. She has 2 patents, namely a system and method to provide ductile detailing in reinforced concrete wall flat slab joint, and the other patent is structural performance of precast shear wall slab connection under reverse cycle loading. She has been recognized with awards such as the Outstanding Concrete Technologist 2020 by Indian Concrete Institute headquarters and Best Woman Engineer 2019 by Institution of Engineers India. So definitely this one more award, definitely she deserves. Besides her research and teaching responsibilities, Dr. Jaya has significant contributions through sponsored consultancy involving the housing sector. She is active in number of professional associations, serves on a number of technical committees, and served also as an independent director in the board of directors of Tamil Nadu Police Housing Corporation. So in recognition of her accomplishments, the Indian Association of Structural Engineers is privileged to confer upon Dr. K.P. Jaya the Outstanding Women Structural Engineer Award 2021, wishing her greatest success and contributions towards excellence in structural engineering. So with these words, I request the President, Mr. Manoj Mittal, to please confer the award, give away the award. Before and after that, I will request Dr. Jaya to say a few words. Once again, you are a professor, but please finish it in 2-3 minutes. Yeah. So, Mr. Mittal, please.
Yeah. Dr. K.P. Jaya, I'm really very happy to present you this outstanding Women Structural Engineering Engineers Award. And I'm highly impressed with your contribution to the structural engineering profession. Kindly accept this award.
Am I audible?
Yes, Dr. Jaya, now you're audible.
Yeah, good evening to all.
Good evening.
Actually, it's my pleasure to be part of this great event. And actually, early morning also somebody called me and told be part of this. So actually, it's my pleasure. I'm really honored of being the recipient of this award. This award has awakened more responsibility on me to continue to spread our, what I can say, provide more my service to the field of structural engineering. I would also like to extend my gratitude to all the panel members. Sir, Prem Krishna sir, I'm very much thankful to you and your team for awarding this to me. I also thank to my parent university, Anna University, who has given me more freedom, more opportunities to spread my knowledge and extend my service to the field of structural engineering. And finally, I'm dedicating this award to my family. Without their support, I cannot extend anything what I have achieved in my life. And especially both my daughters are into the field of civil engineering. That is the extent which I can give unto the society. Thank you very much. Thanks a lot.
I think the citation should have said that both your daughters are civil engineers.
Not only them, and
Yes.
become part of my family. My husband also a civil engineer.
Oh, well, great. I met one of your daughters. She's really, really brilliant.
It's very nice to know that, you know.
First one is doing her PhD in Iowa State University, sir.
Of course, you have many years to contribute still, and then your daughters will continue to contribute to civil engineering.
He is working with Professor Sri Sridharan in the area of precast.
Okay, great.
And second one is just joined with the College of Engineering, Guindy.
Oh,
Great, great.
Congratulations, and very nice to hear you.
Thank you, sir.
I wish you all the best in the coming years.
Yeah.
Thank you. In the same category, the next award goes to Dr. Piali Sengupta. And I will again request Mr. Vinay Gupta to kindly read the citation.
Oh, yes. It's a very interesting citation I have read and beforehand. Now I will go through it formally. It is again Outstanding Woman Structural Engineer of the Year 2021, Dr. Piali Sengupta. Dr. Piali Sengupta, presently working as Assistant Professor of Civil Engineering at Indian Institution of Technology, Dhanbad, ISM, Dhanbad. She obtained her BE in Civil Engineering from Indian Institute of Engineering, Science and Technology, that is IIEST, Shibpur. She obtained a PhD from Nanyang Technological University, NTU in Singapore. Dr. Sengupta has 10 years of professional experience, which includes 1 year of industry experience in projects and operations and MAS, AMC, PT Limited, Singapore, and 1 year of industry experience in MN Dastur Company Private Limited in Kolkata, India, along with 1 year of research experience at Indian Institute of Technology, Kanpur, India. So she has a good mix of industry and academia now. Dr. Sengupta is a dedicated academic and researcher. She has a number of significant innovative structural engineering applications to her credit, namely development of a non-linear hysteresis model to capture the strength of stiffness degradation, pinching, softening, and hardening of characteristics of non-ductile reinforced concrete structural components, development of a modified Park-Yang damage model for damage index calculation and classification of damage state, reliability-based downtime estimation of ultra-deep water marine drilling riser incorporating uncertainties arising from the untested ocean environment, blast performance assessment of highway bridges under near field and far field explosions, seismic vulnerability assessment of buildings resting on hill slopes, seismic sequence, etc. So I think she has left no field untouched. As she's a complete engineer, we would rather like to sort of have some presentations on all the topics that she has covered up so far. And there's, I think, everything that she's covered. Dr. Sengupta has an impressive record of publication and is a reviewer of a number of journals. So in recognition of her accomplishments, the Indian Association of Structural Engineers, ISTRUCT, is privileged to confer upon Dr. Pyali Sen Gupta the Outstanding Women Structural Engineer Award 2021, wishing her greatest success and contributions towards excellence in structural engineering. So with these words, I will now request the President, Mr. Manoj Mittal, to please confer the award on Dr. Pyali Sen Gupta. And thereafter, I'll request Dr. Sen Gupta to take 2-3 minutes to express her feelings about this award. And if anybody she thinks, including students who helped her immensely, please mention that. Thank you. So Ms. Manoj Mittal, please.
Dr. Pyali Sen Gupta, congratulations on winning this award. And really, you have very impressive track record. And very interestingly, I also started my career with M.N. Dastoor and Company in late 80s. And I also worked with the steel structures on, I worked with for Visakhapatnam steel plant at that time. And I hope you will continue doing good work. And if you are not a member of association, kindly become the member of association. And I am really very pleased to award you this, present you this award.
I think she is not there.
Oh, she's not present. Okay.
She was there, but no,
No,
now
she
she's
has just
come.
joined.
Yeah,
Yes,
she's
yes.
just joined.
Yeah, I am present actually. Yes, there was some internet connectivity actually today. I feel honored to get the award, and I give a promise to the community that I will try to contribute more. And I would like to dedicate this award to my teachers, my family, and also my students. And also I would like to thank ISTRUCT for giving me the chance to felicitate at such a young age of my career. I'm really grateful and touched. Thank you so much.
Thank you, and all the best to you. You have many, many years, many decades still to go and go on contributing to the profession. All the best. The next award in this category of Outstanding Women Structural Engineer is to Ms. Papia Mandal. And I'll request Mr. Vinay Gupta to kindly read the citation for Ms. Mandal as well.
Sure, sure. So, Ms. Papia Mandal, she's working for Engineers India Limited as Deputy General Manager, Structural, Gurgaon. And she's a B Civil Engineering from Jadavpur University, Kolkata, and MTech Structural Engineering from IIT Delhi. She's in an endeavor to continue the learning streak. She has further pursued a long duration program on general management and leadership from IIM Calcutta. She has experience of 24 years, having been engaged in series of domain engineering activities with a lead role in several challenging assignments. Following initial grooming, she was assigned a lead role of the LLDP / HDPE unit of the integrated complex at Panipat, executed by EIL on EPC basis. She was entrusted with a very large gas processing facilities in UAE and also a major responsibility in project by BPCL Kochi for the expansion of its refinery, wherein Ms. Mandal was in charge of the most complicated hydro processing block comprising of two major process units, the VGO hydro treatment and diesel hydro treatment. She was further given the lead role in 3 units of world's biggest refineries executed in the world at Nigeria. Ms. Mandal has continued to be entrusted with responsibilities in challenging projects and is credited with efficient results. Ms. Mandal is a fellow of Institution of Engineers, India. Being member of BIS committees, she is actively involved in the drafting of Indian and international standards. She has published many technical papers in national and international conferences and journals. She has guided young engineers to standardize and author a handbook on bolted connections in line with international practices. This has become a company guideline and design practice standard for the company, thus EIL. She has expertise in design of RCC and steel structures and buildings as per Indian and British and European and American codes, and also specializes in blast resisting buildings, dynamic foundations, wind and earthquake resistant structures. Recently, she has been conferred with the FIPI Award, Woman Executive of the Year 2021 in Oil and Gas Industry, special commendation for all-round achievements and traversing a successful career path with professionalism. So, in recognition of her accomplishments, the Indian Association of Structural Engineers is privileged to confer upon Ms. Papia Mandal the Outstanding Woman Structural Engineer Award 2021, wishing her greater success and contributions towards excellence in structural engineering. So with these words, I think I'll request the President, Mr. Manoj Mittal, to give away the award formally. And thereafter, I request Ms. Mandal to say a few words in 2-3 minutes about, as I said, how you feel and how you have been so active in, or what keeps you active in EIL and so on. Please.
Yeah, congratulations, Ms. Papia Mandal, for winning Outstanding Women Structural Engineer of the Year Award. And I hope you will continue good work and also be connected with ISTructy and its activities, so that entire structural engineering fraternity can get benefited by your expertise and experience. I am very pleased to present you this award.
Thank you, Mr. Gupta and Mr. Mittal. And good evening to all the eminent personality present over here, ladies and gentlemen. I feel extremely honored to be recognized as the Outstanding Women Structural Engineers for the year 2021 by Indian Association of Structural Engineers. And I am honestly grateful to the esteemed jury members of the association for this recognition, as I am confident every other nominees for this award was as capable, if not more, to win this award. I would also like to congratulate all the awardees of today's evening. In my professional journey of 24 years in the hydrocarbon industry, I was associated with various domestic and international projects. Some of them were not only prestigious for the company, but also of national and international importance. Upgrading the knowledge base and sustaining the enthusiasm has always remained core to the exciting, rewarding, and relatively productive journey. Winning this award would never have been possible without the benefit of sustaining and unfailing inspiration of encouragement that I have received from my organization, Engineers India Limited, my seniors, and my colleagues. I share deepest respect for them. I remain indebted to my family, friends, and well-wishers, from whom I have derived strength and fortitude to continuously challenge myself, perform better and more efficiently at each and every stage of my career. I take this opportunity to sincerely thank you all for sharing my happiness at this momentous occasion. A big thank you. Thank you so much.
Thank you.
Thank you, Ms. Mandal. Very nice to listen to you. You have a very rich CV already, and I'm sure you will continue to enrich it further in the years to come. Congratulations for the award.
Thank you so much.
Thank you. I now have the pleasure of announcing the next category of award, which is for the promising young structural engineer. And this award goes to a scientist in CBRI Roorkee, Dr. Devadatta Ghosh. May I request Dr. Shilpa Paul to kindly read the citation.
It's a pleasure reading the citation for the promising young structural engineer of the year, Dr. Devadatta Ghosh. The citation goes, born in April 1989, Dr. Devadatta Ghosh obtained his BTech civil degree from Jailpuri Guri Government Engineering College in the year 2010. the Master's MTech in Engineering of Infrastructure and Disaster Mitigation from Academy of Scientific and Innovative Research in the year 2013, and PhD from IIT Delhi in the year 2020, excelling in his academic work throughout. Dr. Ghosh started his career as a scientist in CSIR CBRI Roorkee in the year 2011, and he's presently serving at CSIR CBRI as senior scientist and group leader of data science and special structures. The major contribution of Dr. Ghosh is in the field of structural engineering, especially the development of non-destructive evaluation techniques for civil structures using ultrasound, thermal, and radar waves for assessment of defects in concrete structures, including corrosion-induced damage. He has recently commercialized technology from his work at CSIR CBRI on imaging of hidden anomalies in concrete and masonry structures using ultrasound pulse velocity to an Indian MSME. The technology provides the defect identification in the concrete and masonry medium using the low-cost indigenous UPV devices and will be useful for the quality assurance of the structures. He's also actively involved in conservation and restoration projects for heritage structures, to name a few, such as Sun Temple Konark, Sri Jagannath Temple Puri, Chhatrapati Shivaji Maharaj Terminus CSMT Mumbai, Forest Research Institute FRI Dehradun, National Archives of India NAI Delhi, Rashtrapati Bhavan Delhi, Old Delhi Railway Station Delhi, to name a few. Numerous challenges involved in these projects have led him into innovative efforts, such as multi-wave imaging, developing software, and the design of several low-cost testing setups. He is currently coordinating a DST-funded project on the creation of the Center of Excellence on Indian Heritage Structures. Dr. Ghosh has interest in tsunami and wind disaster mitigation as well, and was involved in the international collaborative projects with the Tokyo Polytechnic University, Japan. His contributions are reflected in his publications in Indian, international, and national level journals and the conferences. In recognition of his accomplishment, the Indian Association of Structural Engineers is privileged to confer upon Dr. Devdatta Ghosh the Promising Young Structural Engineering Award 2021, wishing him great success and contribution towards excellence in structural engineering. So I'm very happy to read the very nice work which has been done by Dr. Ghosh. And I now request our president, Mr. Mittal, to please give away the award to the recipient, Dr. Ghosh. And thereafter, I request Dr. Ghosh to please say a few words. Mr. Mittal.
Thank you. Dr. Devdatta Ghosh, I'm extremely happy to present the Promising Young Structural Engineer Award of the Year to you. I know this is just a beginning and you have a long way to go. Keep doing good work and be connected to ISTT. Kindly accept this award.
Namaskar from my side. Thank you all for considering me for the award. Good evening to all the esteemed members, faculties, students, and all in all whoever present here. Thank you very much, ISTT, for considering me for the award. It is a great motivation for me to receive the award in front of such a august gathering, especially in the event of first Mahendra Raj Memorial Lecture. I am grateful to our director CSIS CBRI for considering me and nominating me for the award. Thank you, Professor Prem Krishna, Professor Mahesh Tandon, who has always motivated me as a RC chairman of CSIS CBRI. I am also grateful to all the members of ISTT and all the audience. I would like to dedicate my award to my teachers, my students, as well as all the family members. I'm also grateful to CSIS CBRI for giving me opportunity to work in many iconic structures. Even I designed the Sri Ram Mandir Ayodhya also in the recent time. So and developed many technologies for hybrid entity etc. So it was great for me to get an opportunity to work at CSIS, CBRI, and get opportunity to design meaning iconic structures. Presently, I'm heading a department, data science and spatial structure, where we are focusing on application of data science for damage detection and construction monitoring, etc. As well as in spatial structure, we are working on building demolition through controlled blastings, designing of iconic structures, etc. So I'll be this award will definitely motivate me to work towards doing something great for the society as well as for our structure. Thank you very much.
Krishna sir, you are on the mute mode. Please unmute yourself.
Yes. I keep on muting myself so that I don't get the noise into your system. It's very nice to see you get this award, Dr. Ghosh, and you're doing great work. A lot of things that you're doing are required by the society, and particularly I'm impressed with your applications for heritage structures, where a lot of more work is required to be done. I wish you all the best for your coming years, and this promise that you have shown will certainly take you far into the profession. All the best. We now come to the youngest level, and that is the best MTech thesis in structural engineering award, which is the award goes to Ms. Malvika. May I request Dr. Shilpa Paul to kindly read the citation?
It's a pleasure reading the citation for the youngest recipient of the IS Shakti National Awards 2021. And as an academician, I feel very honored and very pleased. So because getting the best MTech thesis award, it motivates the students to do good work at the UG as well as the PG level. So the citation goes, Ms. Malvika VA, a postgraduate student of Vellore Institute of Technology, has worked on fracture analysis of thin wall metallic pressure vessels using FEM under the guidance of Dr. A.K. Sharaf from ISRO, Mr. Manoj Kumar also from ISRO, and Dr. A. Sophie from VIT Vellore for the award of MTech degree in structural engineering. The study was conducted to investigate the initiation and the propagation of the cracks in plates, their structure integrity with the surface and embedded cracks using Abacus, the finite element analysis code, wherein the fracture parameters such as the stress intensity factor has been evaluated. The FE model is validated by comparing the results with closed form solutions. The results matched well with the closed form solutions and the experimental results which were done by the candidate. The FEM mesh parameters were applied to the fracture analysis of practical problems of spherical gas bottle made of titanium alloy. A study would lead to understanding of the propagation of the cracks in the materials and the role of cracks in the performance of the structures, leading to the damage-tolerant design approach. The Indian Association of Structural Engineers is pleased to recognize the excellence of the work carried out by Ms. Malvika VA with the Best MTech Thesis Award 2021 and wishes her great success and contribution towards excellence in structural engineering. And I think congratulations, Malvika, and I think this will pave the way and motivate you. So this is just the beginning of your career and which will motivate you to do more work. With this, I request the President, Mr. Mittal, to please give away the award to Ms. Malvika. And thereafter, I request Malvika to please say a few words and share her thoughts.
Congratulations, Ms. Malvika, for winning the Best MTech Thesis Award in Structural Engineering. And I am sure and I hope that you will continue to be an active structural engineering profession after your studies. Congratulations.
Hello.
Good. Yeah. Yes, we can see you and now hear you. Please.
Good evening to all, respected dignitaries. So on this occasion, I express my sincere thanks to all the jury panels in Indian Association of Structural Engineers for awarding me the MTech Thesis Award. Also, I express my sincere thanks to my guide, Dr. S.O.P. from Vellore Institute of Technology for guiding me throughout the project and encouraging me. Actually, she gave me all the encouragement to apply for this award here. Then also, without my external guides, Dr. A.K. Ashraf and Manoj from LPSC Research Center under ISRO, I would not be able to do this MTech thesis. They gave me the opportunity to have work there for an year and made me to bring out the best in me. So thank you to all, and thank you all the panel members for giving me this opportunity.
Good. Thank you. It was very nice to see your thesis. It was very, very well prepared and very good work.
Thank you, sir. Thank you so much.
Are you going into academics or practice?
And now I'm working as guest lecturer. So PhD, I'm thinking, but now
Also you,
just a
higher
break.
education.
Yeah, for a break, I'm doing my job.
Okay. All the best to you. Malvik.
Thank you, sir. Thank you so much.
Well, friends, this brings us to the completion of the award ceremony for 2021. I would like to thank our President, Mr. Mittal, for giving away the awards, Mr. Vinay Gupta and Dr. Shilpa Paul for reading the citations. And of course, congratulate all the awardees once more. I see it's a nice mix of academics, researchers, and people from the practice. It's a well-rounded group of people that have got the awards. So congratulations to them once again. I now pass the baton back to Mr. Alok Bhaumik.
Thank you. Thank you, Professor Prem Krishna, for such an excellent conduct. And also thanks to Mr. Vinay Gupta and Dr. Shilpa Paul. I think it is very meticulously performed session. And what I find very interesting in this session is that out of the 7 individual award winners, 4 of them are women, and that is something which is great. May I now invite our President, Mr. Manoj Mittal ji, to give a vote of thanks to the awardees and for his closing remarks on the award ceremony.
Okay, thank you, Alok. Overall, it was a very nice event, and we had a very good, inspiring, and very emotional, thought-provoking, inspiring message from architect Balkrishna Doshi. Thereafter, we had very fascinating and interesting and informative lecture. First, Mahendra Memorial lecture by Professor Mahesh Tandon, of course, prepared on a very short notice. And thereafter, we had very good session of award ceremony where we presented award to all the winners of 2021 awards. And as I said earlier, this is an annual event. Each year we will have this kind of a celebration. We will celebrate the excellence in structural engineering, and also we will have an eminent speaker to deliver a Mahendra Memorial lecture. So overall, I am very happy that that we could conduct this session. And last year I said that probably we will have this kind of a session in physical mode, in person mode, at a grand scale. But unfortunately, again, we are doing it in online mode. Probably next year we will have at a grand scale in person mode. And I wish that, and I thank everyone, all the speakers, Professor Mahesh Tandon, architect Balkrishna Doshi, Rohit, Raj, for coming and accepting the award given to Mr. Mahendra Raj, and all the awardees who got the prizes today. And I sincerely hope that all the awardees will continue doing good work, and they will be connected to the IS Shakti, and they will contribute and participate in IS Shakti's activities. And if they are not the member of IS Shakti, I will request them to become the member of the IS Shakti, and also encourage their all other colleagues in their organizations who may be interested in becoming the member, that they should join the association, because if we are large, we will have more impact. With this, I will like to conclude my words. Thank you, Alok.
Thank you, Manoj, for your words of wisdom. And I sincerely hope that the next award ceremony is in a hybrid mode or offline mode, if not totally physical, but at least hybrid. With this, we have come to the end of our event today, a glittering event online. And I would request Dr. Shilpa Paul to give a vote of thanks for today's grand ceremony.
Thank you, Alok sir. A very good evening to one and all. Not taking much time at the end of this ceremony, I take pleasure in proposing the vote of thanks for the IS Shakti Award Ceremony 2021 and First Mahendra Raj Memorial Lecture. First, I would like to thank President IS Shakti Shri Manoj Mittal ji and past President IS Shakti Shri Alok Bhaumik, Chairman of the today's ceremony, for all the efforts put in for making the today's event a success and for providing all the support. Thanks to Professor Prem Krishna, the Chairman of the Awards Committee, and his team for putting in untiring efforts for selecting the award recipients under different categories. Thanks are due to Padma Shri architect Balkrishna Doshi sir for sending his video message in the memory of Mahendra Raj sir, and also wishing him best of health. And also thanks to our very own ever smiling face Mahesh Tandon sir for delivering the excellent talk in the honor and the memory of his very own friend and the founding president of the association, Mahendra Raj ji. Thank you, sir, for your time and talk. It was a pleasure always, and as always. I would like to thank all the recipients of the award ceremony, participants attending today's event, and all others who have participated in the award but could not make it. It's a saying that the measure of achievement is not only winning the award, it is doing something that you appreciate, something you believe is worthwhile. Thanks to Rohit Raj ji and Vandana ji for their gracious presence in the ceremony today. At IS Shakti, the legacy of Raj sir will continue, and we look forward for your association with us in the future. I would like to thank our seniors in the association who are the torch bearers for us, who guide us through the process of not only this ceremony, but all the activities of the association. I would also like to thank all the governing council members, all the office bearers of the association for providing their views and sparing their time for the activities of the association. Last but not the least, I would like to thank our secretariat, Vikas Verma and Anamika, for providing us all the support and doing the work meticulously. It's meticulous work that they do, and which is the backbone of the success of any event. So once again, thank you to one and all. Over to you, Alok sir.
Thank you, Dr. Shilpa, for an excellent vote of thanks. And with this, we have come to the end of this award ceremony and the grand ceremony, all the three events. And I declare the event closed. Thank you very much.
Thank you.
Thank you, and good evening to all.
Thank you.
Thank you.
Thank you very much.
Thank you.
Thank you.